this video we are going to talk about how to use a Rust trait for as function callers. Um, so let's see if I have a cargo new it methods. Let's call this as trait methods and pin the binary crate, and so here just reset it. Yeah, we got a fresh cargo project. Open a new terminal. Yeah, we're ready. So as we said, we want a trait with a method which has a parameter as function. So I call it as call this grade as what should I call function caller. Okay, function caller, and let the function template or syntax be call function and ampersand self because it's a method. And what I want is I want a function to be passed, so it should be fn i32 let this return a bool as well. So what we are saying is what we are saying is we need a trait which has a method called function, and whoever going to implement this trait, uh, that uh, type will have this method and which accepts a function, and this will return a boolean. So that is what our intention is. So let's create a type. Just derive debug just for printing purpose, and my struct is my data has just this one field. And what I want here is I should be able to create data from data 32, and I need a caller. where I will just pass this data. I should get a caller if I reference ampersand data. Yeah, okay. And I should be able to invoke it. So basically, what I want is I also need a standalone function. Standalone function will be something like invoke f. This is of type function caller. caller. And what it will return? It will return again. Okay. And what I want to do is let you a maximum value is 5 and let define a closure and I just compare arg against max. What I want is I need to call f dot call function ampersand cl. So this is what I want. But, yeah, and here what I do is println invoke that function. But I assume this caller can be passed because I'm going to implement a function caller for my data. So let's implement impl function caller for my data. And what we want to define, we need to just define that call function method. So let's define that. We got this fine. What I want to do here is basically I just need to call, I need to pass self dot x. That's all. So whenever if a type implements this, it will uh, it will it will call the function passed with the data this method has. Yeah. So basically we can pass any function and it will act on the data in my data and produce something, produce a boolean. Yeah, it's quite a useful function. And apart from that, I would need to invoke this. I'm going to invoke it from outside world, so I need an invoke function and that should just accept anything which implement my trait. So that is what the idea. So I don't know who is going to invoke this, but I just want them to uh, pass something which implements this trait. So that is the idea. So yeah, I think that is the idea, and we are getting some errors. Let's see. Please include dine. I'm okay. I just accept whatever you are saying. Here, what? Include dine. I accept. So that is one thing. Let's do this. Let's do this everywhere. Here, mismatch type. Dine function found reference. Expected is this. Found reference closure expected trait object dynf and found reference. So let's pass why struct has problem. Oh, new method. Okay, yeah. Impl my data fnu it's either to self. It's return as self, and we need to make that self. Yep, that should be fine. Yeah, this all, but still we have this problem. So let's, since we are passing a reference here, reference reference here, it's better to accept a reference here too. Yeah, so it looks like, yeah, it got fixed. So uh, what this is what ampersand time. So yeah, since I am passing a reference to the my data, it will um we need to give that definition everywhere, like ampersand here in the trait, and ampersand here in the implementation as well. But dyne means dynamic dispatching. So yeah, dyne. Let's see what is dyne. Um, dyne keyword. Yeah, dyne rest. Dyne is a prefix for trait object. Dyne keyword is used to highlight that calls to methods on the associated trait are dynamically dispatched. To use the trait this way, it must be object safe. Let's leave it. What is object safe? I'm not sure. Unlike generic parameters, simple trait, the compiler does not know the concrete type that's being passed. Yeah, true. That is, the type has been erased. As such, a dyn trait reference to contain two pointers. One pointer go to the data, another pointer go to the map of method call names to the function pointers, known as a virtual method table or vtable. At runtime, when a method needs to be called on the dyn trait, the vtable is consulted to get the function pointer, and then that function pointer is called. Okay, I think it's when we use this dyn keyword, it creates a virtual method table, and whenever we are calling on some type on that function, um, respective method will be looked up from the v table. Yeah. Um, so I would agree with her dyn. Why I need this ampersand? I don't like using this ampersand. If I just use this, consider borrowing this. I Okay, consider borrowing this and just using here too. Oh yeah, function call function accept ampersand self and self. Yeah, but that doesn't matter. I will go with this. Let me want to see what they just asked me to use the dyn keyword. They did not tell me to use ampersand. I want to see what is the error we are getting here. Yeah, I just see. Oh, uh, dyn thread found closure. Mismatch types basically. Okay, I think yeah, we can only pass a reference to the function. Yeah, so since we are giving reference, it's a closure, so we are passing a reference to the closure. What is the problem if we fully move this? Expected time is an object then. Yeah, yeah, so yeah, it's something some separate type if we simply give this. So if we give this, it's a reference. So since we are using the no giving only here, I need to be time here. I just need a amp. Yeah, business. I'm okay. Agree with ampersand time here because ampersand time here because this is a dynamic dispatch. Okay, this is also dynamic dispatch. Okay, I'm keeping this caller agree. Trait object must trait objects must include oh, trait objects. Yeah, since it's using ampersand self, trait object. Thus provides dynamic dispatch through a feature called trait objects. Okay, trait objects like ampersand foo or box foo are normal values that store a value of any type. Okay, yeah, it's just something which store some type that implements a given trait where the precise type can only known at runtime. Oh, okay. So it's kind of reference or yeah, this box we don't know this inside the type of yeah yeah we can store anything in box, but when we come to a normal value store values of or value of any type that implements a trait. Okay, yeah. Box is kind of box foo or ampersand foo, but the foo will be known only at runtime because it just implements some trait. Yeah. Oh, yeah. Yeah. So so means that means that means definitely this thing we are saying this is our type, and we implemented this function caller for this type. So this is now a trait object. So we need to pass this as ampersand, then only it will go to this dynamic dispatch. Trait object can obtain as from a pointer to a concrete type. Yeah, has to be a pointer. So ampersand, there there must be an ampersand in front of it. These trait object cohesion and cas also work for pointers like ampersand mute, ampersand few. Foo. Okay, fine. And box. Okay, anything work. I think any of these kind of things will work. So basically what they're saying is if you have a type and you know that some trait it's going to implement trait methods, then if you pass your type as ampersand, then 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 you can call the methods. So this operation has been seen. So what did this operation has been erasing hence stated sometimes this operation has been seen as erasing the compiler knowledge about specific type of pointer, and state objects are sometimes referred as type eraser. Oh, okay. Coming back to this example above, we use the same trait to perform dynamic dispatch with trait objects by erasing by casting. So what they're doing, x is equal to 5 u8, say u8 5, ampersand x do something, and oh, we are just casting is to foo, and we are calling a method on it. I see. Yeah. Okay, having said that, coming back to this, so we need to erase the cast. We know that this is my data type, so I'm erasing it with ampersand color. So definitely, yeah, this should be ampersand self here time. Yeah, all these are agreed. Yeah, I don't agree with this thing. What to say? Oh, trait object must include how this can be any type. This can be any type. So this is basically a dynamic dispatch. This is a trait, the version of the call operator that takes an immutable receiver. Instance of fn can be called repeatedly without mutating state. This trait fn is not to be confused with function. Okay, I agree. So this is also a trait. So what they're saying is we need to dynamically dispatch, and in order to erase the type, I believe we are giving this ampersand. So we are saying anything is having this trait implemented, we should be able to call. Since this is ampersand here, we should make ampersand here too. But still, why? What is the problem for this? Trait. Okay, this is also a trait object. True, true. We don't know the type. Dyn keyword must be used. Okay, I'm using dyn, and we need to erase the type too. Yeah, let me say. Trait sized is not implemented for that. Okay, so in order to make it as unsized, sized, we are giving an ampersand. So that way it's compiling. Then now let's cargo run it. Yeah, true. So what happened is 32. We just invoke this our type. We just given it as a pointer reference. So it went to this invoke function, and there's a max value, and this is our argument. We are creating a closure, and closure will get an argument. That argument will be compared with 5, and if it's greater, it will return true. Where it will return true. Yeah, this r greater than max means it's a condition. If condition is true, it's return a boolean, true boolean. So we are passing ampersand uh, mycl's closure here, and since we implemented since we implemented since it's a trait, since this trait is implemented for our type, this is not, maybe we can keep it as some other name. My type caller, type caller. Yeah. Since we know that our type is implemented the function caller, so just take my type, go to my type virtual method table and get respective function. That is what the meaning of this. I don't know, might be type passing different types, but Only thing is the type will be implemented the straight and go to the respective um, virtual method table and get the respective function. That is what the meaning of this. So having said that, we can take this and call function. This compiler will understand uh, what method needs to be called. So this time this is the method because my data implemented call function and passing this and how this arg is getting from here. So this function whatever closure passed will be called with this argument self.x. So that is where we are getting my data state or inside value. Okay, I think that's all I want to cover for today. I will try to see um, we will try to see whether we can convert this to an method async version of this program. Okay, thank you for watching. We will see some other day. Thank you.